Hello and welcome to today's Partner Web Conference. This is Fast Track Dynamics 365 for Finance and Operations Tech Talk. Today's topic, Dev Application Lifecycle Management. Presenting for us today from Microsoft, we have Senior R&D Solution Architect, Eric Pegors. So without any further delay, Eric, welcome and thanks for joining us.
Thank you, Janice. Okay. So the first thing we want to talk about is our business process focus, and we want to make sure that all the things that we do for ALM are tied to a business process. And for that, we have the business process modeler, and those business processes can be synchronized with Microsoft Azure DevOps, which is the replacement for VSTS. And we want to review processes and track the progress of your implementation project and associate our various work items and check-ins with requirements and business processes. So this is the overview of ALM, and we have development and build and deploy, and those are the topics today. And you can see that there's environments associated with each, and DevOps is used as to hold the source code and make everything consistent, so the development machines get the source code out of DevOps and put it in there. The build machine takes the code out of source control and creates a deployable package, which will be put in the shared asset library, and then the deployable packages are deployed to UAT from the shared asset library, and after UAT, the deployable package can be marked as a release candidate and then installed in production. The first thing that we're going to talk about is version control. It ties everything together, and version control using Azure DevOps or DevOps is required, and the main reason we use version control is not specific to Dynamics 365 for finance and operations, but it's consistency. Right? This makes sure that all of our developers have the same code, and all of our deployable packages have the same code, and it's consistent. I mentioned before, DevOps is the successor to Visual Studio Team Services or VSTS. In DevOps, only Team Foundation version control is currently supported, which means Git is not supported. When you create a project, Git is the default, so make sure you change that to Team Foundation version control. And version control has well-known benefits. It keeps a backup of all your code. It has history and traceability and rollback if you need to undo something. And it also supports branching. Primary purpose is storing the source code. That includes customizations, ISV products, and currently it includes hotfixes. With the one version initiative, the need to store hotfixes will be removed. We'll talk about that a little bit more later. And the source code for finance and operations is primarily the XML text files that make up the application object tree or the AOT. They're stored in the packages folder on the development machines, and we'll talk about those as well. A DevOps account is free. It includes 5 basic licenses, and a basic license is what you need to access the code. The stakeholder licenses allow access to work items, and you get unlimited stakeholder licenses, but the free account comes with 5 basic licenses. If the email that you sign in to DevOps with is associated with an MSDN subscription, then you can access code without using one of those 5 licenses. You don't need a basic license. The MSDN license is a substitute. And you can purchase additional basic licenses in the Azure portal. They're not that expensive, something like $50 a year. All of the use of DevOps by finance and operations is standard. So all the regular documentation that exists and books and all those things are applicable. The only one thing that we do have special is that our code upgrade looks in the trunk main branch as the input for the code upgrade. Otherwise, we don't have anything specific to finance and operations. So when you're in terms of version control, make sure that the owner of the intellectual property owns the DevOps account, and we recommend that the customer own the intellectual property and the DevOps account, and that DevOps account is connected to the customer's Azure Active Directory for authentication. That also gives them the connection to the Azure subscription, which allows you to purchase extra licenses and is the main thing that you would want to purchase. As far as the free account supports everything you need to do free and with those 5 licenses. The default URL format did change when the name was changed to DevOps, and the VSTS URL format still works and is required by LCS, but either one will work and there's no issue. You just have to, even if you created it now, you can just type it in the old format and it'll work. Okay, so we want you to consider the minimum branching option, and this was kind of the option that we used about 2 years ago when finance and operations was much newer and things were generally just simpler. But that is to have one branch, and in trunk main, since that's where the code upgrade looks, you might as well have it there. And then what happens is the developers check into that branch, you run builds off that branch and install them on the tier 2, and you deploy it to production. And because everything in a branch gets included in the build, if a change fails validation in this one branch model, you either have to fix it or remove it in order to get a build to production, right? So, and I think that maybe shows the limitations of one branch, but the simple flow is the developers check in the code, the build machine creates the deployable package, which goes to the sandbox, and the release candidate goes to production. The preferred branching option is to have 3 branches, and you're free to have whatever branching you want or need for your project. There are entire books written on branching, and again, we don't have anything very specific, but our recommended branch currently is branching option is 3 branches. We'll have a dev branch, which is used for developer check-in and testing with development data. The test branch, which we call it the test branch, but it's in trunk main folder, and that is where you check in or you merge development features that have passed development testing, and you're going to run a build, create a deployable package, install them on the tier 2 or above, and test them more thoroughly using current production data, because of course a tier 2 can be refreshed from production. Then we have a release branch, which is all the features that pass testing in the test branch will be merged to the release branch, where you'll repeat the process of running a build, creating a deployable package, putting it in the tier 2 and revalidating, and then marking it as a release candidate and sending it to production, assuming the validation is good. The difference is that in test, the features that fail validation are not moved forward, and we only put things that are validated in release because of the what I mentioned before, that everything that's in the branch gets put in the build. So if that feature that doesn't work is in test, we can't send one of those builds to production. And this picture shows the branching flow. So when you create, you start with main or test, and then you create a dev branch from that, and you create a release branch from that. But the central is the test branch or trunk main. And the code upgrade will create a branch from test based on the code upgrade, and it's in the releases folder, which is different than the release branch. That was the branching. Consider the movement of code between the branches. The normal movement for code is developer checks it into the dev branch, it's merged to the test branch and validated, and if it's valid, it is merged to the release branch. A code upgrade is kind of a full reset, and it's less necessary with one version because of extensions and that they are durable across over time, whereas overlayering needed to be updated when you merged or when you upgraded from a major version. But anyway, when you get your code upgrade run into the releases branch and you get it all cleaned up, then you push it all into test branch, and that sort of starts everything over. And since it starts over, you have to move it on to dev following the normal branching. Dev runs from main. Just a little bit more about the dev branch. Do map your development machines to the dev branch. Do use frequent check-ins to keep work safe, and that's the good thing about, right? That's why you separate it, because if something is half done, you don't want to check it into the test branch because you don't want it to be tested in the production data, but you are free to check stuff into the dev branch as frequently as you want, and that will keep it safe because it's a natural backup of that code. Do check in the changes for all features. Don't leave stuff sitting on your dev box, and do use a single change set or for each feature. Don't put multiple features in one change set. It's okay to have multiple change sets for a feature, but the reason is because whatever granularity you use in the dev branch, that's the most amount of granularity you can use when you merge stuff to test, and you want to be able to merge each feature independently to test and beyond. And then for your dev branch, consider the cost of a bad check-in where it causes a build error or something when determining the build trigger, because you can set up a build to run on your dev branch, and a simple example is to set one up every night at 6 o'clock. So after everyone goes home, you run a build to make sure that the branch still compiles. Those builds aren't used for anything except verifying that it still compiles, so you put them in the garbage can when you're done. The test branch or trunks used by merging the features, the individual features from the dev branch that have passed development testing and they're ready to be tested more thoroughly in the tier 2 environment with production data. You have to merge each feature in a separate change set so you have that granularity. And since you merge manually, you normally just start your builds manually. After you merge some features, if you want to install them on the tier 2, you start a build. Don't map any development machines to the test branch. And the flow is on the bottom. Dev branch, merge it to test, run a build on the sandbox, and then the test branch builds are never put into production, so put them in the garbage can. Don't mark them as a release candidate. The release branch has a lot of similarities to the test branch. Only merge features from the test branch to the release branch that are ready for production, so they passed all the testing in the test branch. Again, merge them in a separate change set because based on the rule that everything in a branch builds, if something would fail validation for some reason. Maybe it's the feature that was left behind in test affected this feature, and this feature doesn't work without it, or something. It would be relatively rare, but we absolutely want to revalidate the build from the release branch, because it's not the same build. Don't just install it in Sandbox to get the release candidate. Also validate it, and then mark it as release candidate and send it to production. And still use manual builds, and don't map your development machines to the release branch. A few anti-patterns for version control. We already mentioned this, but don't map development machines packages folder to the test or release branch. I'll talk about this in a little bit, but what the packages folder is mapped to is what really is important. Do not check in changes directly to test or release. Keep all your features in one feature in a single change set, or one feature in multiple change sets, but not multiple features in one change set. Do not mark deployable packages from the test branch or the dev branch as release candidates. And don't put untested features into the release branch. This diagram shows a hotfix and then a release 2, which would be a different version. Again, this is less applicable now for one version, but you do need a separate build machine for each application version, and you need a way to service production while you're working on an upgrade. And there will be a lot of upgrades going on in the near future, so that's important. And you need another sandbox on, you need a sandbox on each version as well for testing and whatever. Okay, so now we'll talk about the development, and we always start with a quick update or a quick reminder on packages and models. A package is a compilation and deployment unit of one or more models, and a package includes metadata, assemblies, and other resources. So you can kind of think of a package like Application Suite as application suite.dll, and the package is what gets installed on the runtime environments, and it does not contain source code. There's no development tools on tier 2s or production. There's none of that stuff is there. It only accepts assemblies and other things that are ready to run. One or more packages can be added, can be in a single deployable package, and that's what we use for deployment on runtime environments. And in fact, we encourage you to have all your ISVs and all your packages and whatever else you need in VSTS, so that your build machine creates a deployable package that contains all of your code at the same time. That's again for consistency, and we'll have some more information on that in a minute. A package is also referred to as a module, not a model, but a module. And the module shows up in the LCS asset library. When you click on a deployable package, it'll show the list of modules, which is application suite.dll and those kinds of things. There'll be a list. On a development machine, a package has a top level folder in the metadata folder, and that's in version control as well. So application suite, package, AOS service, packages local directory, application suite is a package folder. And here's a picture mostly for the recording of the package folder in a development machine, and there's application suite highlighted. And I'll make a note that on the left side there in Windows, if you if you're in the AOS service folder and you can see the packages folder, you can put a shortcut to the packages folder under the quick access there, and that's very handy for saving you time, because you may go to the packages folder quite a bit on a dev machine. Now a model is a group of source elements such as metadata and source files that make up a software solution. The model is a design time thing, and it contains this actual source code. The key to a model is its descriptor. A model has a folder in the package folder in the packages folder. So the packages folder contains all the packages, like application suite is one of them, and the model for application suite, or one of the models, is the foundation folder. And so it's handy. A lot of the models and packages have the same name, so you'll see an application platform package and an application platform model. Application suite has a different name, so that is handy for an example. And the descriptor is stored in the descriptor folder of the packages folder. So it's in the package app suite descriptor, and then the name of the descriptor is the name of the model. So foundation.xml in this example. And this is an example of a model folder in the Windows Explorer, and inside the model folder are all the subfolders for the actual AOT items, such as AX class, AXEDT, aggregate data entity, and all the rest. So this is an example of what that looks like. A day in the life of a developer is something like this. They RDP to their development machine. They perform a get latest in version control. That gives them all the things that their coworkers checked in since they left for the day, or since they did the get latest last. They can work on their features. They can collaborate with business users because the cloud development machines have an AX website that they can collaborate with business users, and they can sign into that site and do testing and validation or set up data on those features that are being developed. A side note is that for a VHD, you have to be on the RDP to the machine to use its website. It's not available on the internet. And then the developer will check in their code to version control when the feature is complete. And it's relatively quick and easy to get a new development machine or a new developer up and running. So either you have a new developer who comes in and they need a new machine, or this developer, an existing developer, wants another machine or wants to replace their machine. It's pretty straightforward, and we'll talk about some of that. To configure a new development machine, you need to open Visual Studio and sign in using the account connected to your Visual Studio license. You do need a Visual Studio license for development work, and those are around $50 a month. Also, MSDN does work as well. And then you can connect Visual Studio to version control, and all of the, like I mentioned before, this is all standard DevOps and Visual Studio stuff. It's nothing here is specific to finance and operations. And you can use a different account for your license and your version control. It supports that. After that, you map your version control folders to the local machine, and then you build the needed models. The build is usually pretty fast because starting with one version, you don't have to rebuild application suite anymore because you're not allowed to change the source code in that. And we'll talk a little bit more about that too as well. This is a picture of the workspace mappings for a new development machine that need to be set up. The first two are the required ones, and you map the metadata folder to the packages local directory, and you map the projects folder in version control to My Documents Visual Studio 2015 projects. Now the other two lines are mapping of the test project, or the test branch and the release branch to the temp folder on this machine. When I said you don't want your dev machine mapped to test or release, I meant it, but you can map them to I meant to the packages folder. You can map them to the temp folder, and that is needed for doing merging, to have them mapped somewhere on the machine. You don't have to download the code, and you shouldn't check in code. But the main point here is the first two lines, how you map a development machine to version control. And the name of the project in this case is Dynamics 1611. So then the rest of that will be the same for every person. Do make sure that each developer has their own DevOps license and login. That's that basic subscription that we talked about. Do make sure that they have their own development machine. It's because of those mappings on the previous slide that are mapped to the packages folder. Two people cannot share a development machine, at least not at the same time or not easily. Make sure that each developer has their own Visual Studio license as well. Make sure you reference the feature item when you check in, and we talked about that, the business process modeling. And consider including automated tests using the SysTest framework, and consider using test-driven development techniques. Also, when you're doing development, consider non-functional requirements such as the expected performance and throughput. Implementing, as an example, implementing more performance than is necessary will take longer than it should, and implementing less performance than is necessary will often result in rework that will likely be expensive and time consuming. If you implement something the wrong way, that it doesn't perform well enough and you have to redesign it, it may be like starting over. So that's a couple things to think about when you're working on development. We talked about KB installs, and this was KB installs before 8.1, version 8.1, were released as source code. This kind of has, the legacy is that it's related to overlayering, but you do need to install them from the command line. The Visual Studio add-in is not as reliable as the command line, and especially if it's a larger KB with more files in it, the command line is a lot more reliable. Make sure you use the version control option. This is the only way that, well, first of all, it goes back to our consistency, so that all developers will pick it up immediately when they get latest, and it's the only way to get them onto a build machine. That's how the build, only thing that will be included in a build is what's in version control. Do use the following procedure: execute the prepare, and then check in the pending changes for the prepare. The prepare takes whatever is in the KB. Let's just say that this KB contains the ledger journal trans table. It will take the version of the ledger journal trans that's sitting on that machine, which is the original version, and it'll check it into version control. And the reason it does that is because after you execute the install of the KB, then a new version of that ledger journal trans table, or I'm sorry, well, file will get put on that development machine. And after you check that in, then you'll have two version control events for the ledger journal trans table: the add of the original and then the edit to that KB version. And the reason that the prepare is needed is that if you want to roll back the KB, you can do that in version control, there's no problem. But if you don't run the prepare, when you roll back the ledger journal trans file, there won't be a file there unless you had added it to version control first. And it is needed, and it won't, and the machine won't build without it. And it's fine to get the ledger journal trans off of another machine of the same app version, but if the KB had a lot of files in it, that's a real problem. So you want to make sure you do a prepare so you have a all of the original files in version control in case you need to roll back the KB. The one version KB install is not applicable because starting with application version 8.1, all Microsoft code is being released as a binary update, which means we just send you the application suite.dll. The source code is put on the dev machines when you install that. The KB on your development machine, and they're also cumulative. So if you just install update 2, you'll get update 1 as well. As you can imagine, the assembly has to contain everything. You can't piece it together. Like that's what we would do. We would just send you what changed in the KB, and then you would build everything. And do remember that this is all possible because of the switch from overlayering to extensions. By not allowing source code modifications, we don't have to ship updates as source code anymore. We still give you the source code that corresponds to the update, but that's been done by the platform for a long time, right? The development machines have also had the platform code, even though the platform has been binary-only releases for a long time. Related to ISV products I mentioned earlier, do check the ISV source code into version control, especially if you don't have a binary. You have to if you don't have a binary deployable package from the ISV, because to use on your tier 2 environments. That's because that's how you get it on the build machine and get it included in your package. And that was more a case related to when there was overlayering as well. You also want to check the binaries from your ISV, if that's your current model, into version control, because you want the build machine to run a build and include the ISV module in the deployable package, so you have one deployable package that contains everything. You can install, if you get binaries from your ISV, which is going to be more likely with one version, you still can install the source code on your development machines as needed for debugging and stuff. And consider that ISV source code may be shared with a model file that was created manually or by an automated build. Development anti-patterns. Don't let developers hold their changes on a development machine for too long without checking into DevOps or making a backup of some kind. Do not let developers share a development machine or DevOps logins to ensure traceability and accountability. If all the check-ins are done by the same account, then it's really hard to figure out what really happened and how to prevent problems. Do not check in for changes for multiple features in a single check-in, and do not use Visual Studio to create deployable packages. In one version, 8.1 and greater, a deployable package that's not created with a build machine will not be allowed to be installed on a tier 2. The LCS can tell that it was created by Visual Studio and it will reject it. But it's always been a best practice to not use Visual Studio to create a deployable package. Main reason is because whatever is sitting on that development machine, whether it's something that a half-done feature or a class or something that the developer wrote to test something or whatever it is, would get included in the deployable package, and that may not be what was intended. Okay, let's talk about builds. And for this topic, we're talking about automated builds using a build machine. And the build is the process of taking the source code from the models that we talked about and producing the binary files, which are combined into a package that we talked about. No code can ever run without performing a build first. And the database sync runs code, and it can't be done without a build, because again, the schema is retrieved from the assemblies that come out of the build and not the raw source XML files from the AOT. The reason we mention this is because in AX 2012, the build was sometimes taken for granted because all environments, including production, had the ability to do a build, and sometimes a build would kind of be done even though just by closing the form. It was a little more subtle in some cases. It was definitely happening behind the scenes, but the production environments did have the ability to do a build, and our production and runtime environments like Tier 2 and above do not have the ability to do a build. Automated builds serve multiple purposes. On the dev branch, we mainly just use them to make sure that all the code checked into version control compiles without errors. It's very common for a developer to forget to check in one of the files for whatever reason. People make mistakes, and the build will run. It will build fine on that dev machine because the file is sitting there. But if it's not in DevOps or version control, it will not build, and that's why you run that build at 6 p.m. on your dev branch at a minimum, and to catch things like that and make sure that missing file gets checked in. A build can also perform automated testing after the build is successful, but as part of the build process. Sys-test-based tests can be run as a part of a build as well. And the build also creates that deployable package that we need for our Tier 2 environments. We recommend creating a single deployable package that contains all the modules or packages. I've mentioned this a couple times, where you want to have your customizations in your ISV code and all of those, and anything else that matters in one package. Before one version, that would include application suite because of hotfixes, or other Microsoft modules because of hotfixes. A build can be started manually or automatically using build triggers. A scheduled build is the one we talked about, the minimum for the dev branch, just started at a certain time of day. Continuous integration will start a build as soon as the check-in is performed. You check in, then it kicks off a build. This is one of those automatic ones, and it'll just run. A gated check-in is similar, except that when you submit the code, it holds on to the check-in, and it runs a build using that proposed change, and then it will check it in only if the build succeeds. If the build fails, the check-in will be rejected. And then you can also start a build manually anytime you want from the DevOps website. All of the interaction, all of the normal interaction that you do with the builds can be done from the DevOps website. There's very little need to RDP to the build machine. You should not be doing that on a regular basis. It runs by itself, and you use it through the DevOps website. Some of our best practices: do schedule an automated build at least daily to ensure errors are caught early. The more advanced options are continuous integration or gated check-in that we talked about. Do verify the developer. Remember to add or update all the objects in version control. We talked about that. Do find build errors caused by conflicts between developers. And consider using continuous integration or gated check-in triggers. The more developers you have, the more those might make sense. Do not install dev branch deployable packages on any environments. You run the build just to make sure that it builds clean and everything works, and then you toss them. On the test branch, because you merge things manually, you normally start the builds manually. After the merge, you start a build, you install those deployable packages on a Tier 2 environment for testing using recent production data, and you don't mark them as a release candidate. They stay in the asset library, but you don't use them after they're installed on the tier 2. The release branch is similar to the test branch. You merge manually, you start the builds manually, you deploy it on the tier 2 for testing using production data, and only if it passes validation in the release branch do you mark it as a release candidate for to go to production. And you do not skip testing the release branch deployable package because the same features were validated in a test branch. You revalidate on the release branch build. Build machines, you do have to have one build machine for each application version. So if you're working on an upgrade, you would need a build machine for your old version and a build machine for your new version. Within one application version, you can use a build definition for each branch. So that does not require another machine. It just requires the build definition in the DevOps website. And you also use a different build definition for each build trigger. So if you have combinations of branches and triggers, you'll have that same number of build definitions. Do use consistent naming for your deployable packages. Here's a pattern to at least consider: the company, the branch, the app version, and then I like to use the DevOps build number, which is basically the date with a sequence number. So this was the first build done on August 6th. And I include additional information in the description, such as the KB or the, this is the naming of the deployable packages when you add them to the asset library in LCS. So in this description, I fixed this one problem, which presumably this is the first build that problem was fixed in, and I also installed this KB. That's the summary, but the name tells you everything else you need to know as far as date and build number, and you can correlate that to the version control. Build anti-patterns. Do not RDP to the build machine. You can do everything you need to do from the DevOps website. If you haven't RDP'd to the machine, you can't open up Visual Studio or map it to the branch and version control. You should not do that as well. The build sets up its own mappings every time it does a map, and don't use Visual Studio to create a deployable package. Here's a few examples of some deployable package. This is a typical deployable package that was created by a build machine, and you can see it's got App Suite and all this, and that's because this is a 7.2 application, but the one that's anonymous there is their customization package, but all the others are here because of KBs. Okay, and the reason that we like a build machine is because it's self-contained and it contains all the applicable modules, and there's sort of a matched set. The one on the left here has directory, which is a KB, and it has the customer, and it has ISV1 and ISV2. If you created it from Visual Studio, as on the right, you might have made a change in those other modules, and you didn't make a change in directory, so you didn't include it, and now you have to sort of figure out if you've got the right directory version is the idea. Same thing with more common would be for you to fix something in your customer extension or your app extensions and only include one module in this deployable package, but then it really depends on everything that was installed previously. So it can be tricky to make sure you have a good set. So not to mention, the other reason that we recommend everything be in one deployable package is because there's a lead time to install a package on production, which makes it difficult to install more than one package in a night without somebody staying up fairly late. So that's why we recommend one big package that came off a build machine. Okay, we'll talk a little bit about deployment, which is installing deployable packages to the tier 2 and above environments. The build creates the deployable package, and then in DevOps on the website, you can go to build and release, and I know that they change these names sometimes, but you can find the build, and a good thing to look for, the build numbers are, this one has that little green arrow or green check mark by it. They're the date with the sequence number, that's the build number. So if you find the build number, you can click on it, and then choose View Build Results in this case, and that'll show you like a page just for that build, and that Artifacts tab, and then Packages has a that's where the deployable package is at, and I'll just show on this one on the far left, if the build would happen to fail, the green would be red, and the Logs tab, which is on the far left, would contain the information about what failed. And I again highlighted the build number at the top there. Once you're on the packages, you can open up the Explorer, and you can see the deployable AX deployable runtime zip file. That's the deployable package with the assemblies inside. That's the runtime is the key, and all you need to do is click on the 3 dots and download that, and then you can upload that into the LCS asset library as is. The file name that begins with AX model source is the source code from that build, which may be useful. It used to need to be released like by an ISV because of overlaying. Now that's generally not, with one version at least, that's not necessary, but it still sometimes is handy to have the build, a copy of the source code that was included in this build. And we are working on a feature to automatically put builds into the asset library, but today you have to download it this way and then upload it. The deployable package can be deployed to a finance and operations environment after it's in the asset library. On the environment, you choose maintain, apply, and the list from the asset library will show up. There is an option for uninstalling a module, which is getting that assembly off of that machine. And the first thing you need to do is sort of isolate the module that you want to remove. And the first thing you do to do that is you deploy an update to all the modules that you're keeping to remove any references to the module you're getting rid of. So if you have customizations that used to use the module you want to remove, you need to remove your reference and then fix all your code to not access that module. The next thing you do is delete everything out of that module, all the source code out of its models, except leave one class, so you sort of have a very small and package that references nothing and nothing references it. And then you can use the help topic description to create a deployable package that contains a list of modules to remove, and where you would name that module, and when you install that deployable package, it will delete it from the machine, from the packages folder. That's the end of the presentation. Thank you.
All right, thank you, Eric. All right, ladies and gentlemen, I'd like to take a brief moment here and bring your attention to a link that I posted in the Q&A panel. That's a link to a short survey for this web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference, have feedback on how we can provide you with a better event, or you'd like to suggest topics for future web conferences, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. And that is going to conclude today's web conference. Attendees can access the web conference recording via the same registration link used to attend today's live broadcast. I'd like to extend a big thank you to our presenter, Eric, and thank you, audience, for logging in and joining us today.